Chapter 1 practice test for you for Introduction to Calculus. So the link to this practice test will be on the description and you can go there and download it. Or if you don't have a printer, never fear, just stop the video, try the questions, and come back and check your answers. So let's go. True or false? All polynomial functions are continuous for all real numbers. What do you think? True. Of course it's true. All polynomial functions. Those are like quadratics, cubic functions. They go and they go and they go on and on, right? There's no holes in them. If there is a point discontinuity, then the limit does not exist. This is false because you do know that you could have something like this. So the limit from the left equals a limit from the right. The point doesn't have to exist in order for the limit to exist. C, m, which is slope here, is the limit as h approaches 0 of f at x plus h plus f at x over h. And you probably noticed that is false because there should have been a minus sign here. It's the difference. It's like a slope function. The limit as x approaches a of f at x is called a two-sided limit. Yes, it is. That's a two-sided limit. You're checking the left and the right, even though they don't put the little plus and minus signs on the side of it. Okay, easy 4 marks, right? Rationalize the denominator and simplify. So remember, to rationalize the denominator, you multiply by the conjugate. So the conjugate for this, let's write out, it's 3 root 2, and all we have to do is change the sign. So minus root 7 over 3 root 2 minus root 7. Remember why we do that? Because it makes this become without radicals, right? So if we expand, remember you have to do everything by everything here. So that gives me 9 times the root of 4 is 9 times 2. I'm going to skip right through. 9 times 2 is going to be 18. So we have 18 here, and we have minus 3 root 14. And then we have this times this one, and that's going to be minus 3 root 14 again. And minus root 7 times minus root 7 is minus 7. So that gives me just the square root of 49. It's going to be plus though, right? Plus 7. Okay, so that's going to give me, did I do this right? That was 9. 9 times 2 is 18. Okay, all is good. And in the denominator, I have 3 root 2 times 3 root 2. Remember, this is just going to get rid of these. It's going to be minus it. So 9 times 2 is 18. And then we have root 7 times root 7 is 7. And we're subtracting it. So we're going to end up with, I didn't leave a lot of room for some of these questions I noticed. So 18 plus 7, that's 25 minus 6 root 14. All over 18 minus 7 is 11. Okay, so now the next part, we're going to determine the slope of the tangent to the curve. Y equals 5, the square root of 5 minus x at x equals minus 3. So what I want to do here is I want to use, of course, what you've learned in this chapter, and that is the slope calculation. So, I don't know how your teacher wants you to write it. You might just write m equals, or maybe they taught you to use primes. So you could say, what I like to do is say let y equal f at x. And then I have f prime x. So you might be, like I said, you might just have an m here. You might have said y prime. I'm not sure. So whatever your teacher has taught you, that's what you should be using. So I'm going to say f prime x equals the limit, don't forget the limit, as h approaches 0 of f at x plus h minus f at x. So hopefully if you made the mistake up there, you would have figured it out down here. Or heaven forbid that you use this equation down here. Okay, so that's what I want to fill in. So over here, I'm just going to say what all these things are. So I have x is minus 3. So what is f at minus 3? Plug in minus 3 here, 5 minus minus 3. So that's going to be the square root of 8. And x plus h is going to be I'll put this one over here. X plus h is going to be x minus 3, or 3 minus h. Sorry, not x. X plus h is going to be minus 3 plus h. And f, we need a little bit more room for that. F at minus 3 plus h is going to be equal to the square root of 5. Now you're plugging in this, so it's minus it. So that's going to be plus 3 and minus h. Excuse me. So that's going to give me the square root of 8 minus h. Okay, so I have these, and now I can just kind of plug them in over here. So this is the limit as h approaches 0. So f at x plus h is the square root of 8 minus h, minus f at x, so that's going to be minus the square root of 8 all over h. Now, in order for you to get rid of this h somehow, you have to do some more work, right? And that means, because we have radicals here, we're going to multiply by the conjugate, which is what we did up here, only this time we're rationalizing the numerator. So 8 minus h plus the square root of 8. And in the denominator, we have the very same thing. Whatever you do to the numerator, you do to the denominator. Okay, so keep writing this limit too. Don't forget, limit as h approaches 0. So I'm just going to expand this. So because it's minus and plus, that means I just have to square this one and minus the square root of that one. So if I square this, I get rid of the radical sign. If I square this, I get rid of that radical sign. And in the denominator, I still have h times all of this stuff. 8 minus h plus root 8. Make sure your sign goes right over. Okay, so 8 minus 8, that's gone. The h goes into here minus 1 times. And this is what I have in the denominator. So I'm still looking at, until I plug in that 0, you keep writing the limit as h approaches 0. So it gives me minus 1 over the square root of 8 minus h plus square root 8. And now I plug in the 0 and get an answer. So I have minus 1 in the top. If I put in a 0 here, I have the square root of 8 plus the square root of 8. That gives me 2 square root 8s. Okay, don't forget, when you add radicals, that's what you would get. Okay, flip over here, page 2. It says, a ball is thrown into the air with a velocity of 30 meters per second. Its height in meters after t seconds is given by this equation. Calculate the average velocity. So, you know, average velocity is slope of a secant. And that's what it's going to be down here when it says interpret the meaning of your answers. Okay, so I'm going to say when t equals 2, because I want to find the y-coordinate for 2 and 4 seconds. So y is equal to 30 times 2 minus 4.9 times 2 squared. And I did that somewhere here to save us some time. That's 40.4. So I had to do this test for you. So that's why it took me so long to get this up, because I had to find a good one. And then I had to do it for you. So this is going to be 30 times 4 minus 4.9 times 4 squared. And that comes out to 41.6. Okay, so now I need to find the average rate of change, R of C is equal to, so it's a slope calculation, so that's 41.6 minus 40.4 divided by 4 minus 2. Write it out like that so you remember where it came from. And that comes out to 0.6. So then you make a concluding statement. Therefore, the average velocity between 2 and 4 seconds is 0.6 meters per second. Don't forget you need units for that, right? Okay, goes from A to D. That's great. This should be a B here. Teachers make mistakes too, don't they? Calculate the instantaneous velocity at t equals 3 seconds. Do not use your advanced functions method of a small interval, but rather what we learned in this unit to calculate. So this is where I really didn't leave enough room to answer this part of the question because it takes a lot of room. So maybe what I'll do is I'll start it way at the top of the page here. So I want the instantaneous velocity at t equals 3. So I need to know what is f at 3 to start with. So I want to calculate f at 3. So I'm going to put in, that's going to be like 30 times 3 minus 4.9 times 3 squared, right? And f at 3, that comes out to 45.9. And the second one that is much more work, I want to know what is f at 3 plus t. So that's going to be 30 times 3 plus t minus 4.9 times 3 plus t squared. Okay, now don't forget, in order to multiply this out, you have to square this binomial first. So I'll just start it and then I'll give you the answer. So that's 90 plus 30t. And then I'll expand this. Remember, square twice the product squared. And now you have to expand all this, simplify, and you're going to get this for an answer. Minus 4.9 t squared plus 0.6t plus 45.9. Okay, so that's what you should do before you start. You have your f at 3, your f at 3 plus t. And this is instantaneous velocity. Maybe your teacher just called it slope. Don't worry if I'm writing f at 3 plus 2. So now I'm going to find the slope here. So f prime at 3 is going to be, so I'm going to do f at 3 plus t. I don't have enough room to write all this out, but you know the limit should be f at 3 plus t minus f at 3 all over t as t approaches 0. So I'm going to say, just continue it here. The limit as t approaches 0 of minus 4.9 t squared. So this is my 3 plus t. And I subtract f at 3. And that makes me very happy to see that these are the same. And yours, they have to be the same because we need to be able to divide this t into the numerator. So you have to eliminate this because you can't evaluate the limit at 0 if you have a t down here. So notice how nicely that goes away. And then I end up with this. The t would go into both of these. So this is going to be the limit as t approaches 0 of minus 4.9 plus 0.6. So as t approaches 0, oh, I forgot the t here. Still one t, and this one doesn't have a t. Let me just make that a little prettier for you so you don't say I can't read your writing there. Minus 4.9t plus 0.6, and as t approaches 0, this becomes 0, and we get 0.6. And that would be meters per second as well. Okay, so the average rate of change and the instantaneous rate of change ended up being the same thing. Okay, interpret the meaning of your answers. Well, part A is the slope. A is slope of a secant between 2 and 4 seconds, whereas B is the slope of the tangent at 3 seconds. So that's your instantaneous rate of change, maybe your average rate of change. Use all the words you can find. Okay, number 5, determine the equation of the tangent to the graph y equals 4 over x minus 2 at the point x of 6 and 1. So what I need to do is I need to find the slope, right? I need the slope first. So let's do the let y equals f at x here again. I don't like working with y's. I like f primes. So f prime x is equal to the limit as h approaches 0. And you should know this so well by now, because I'm sure you did lots of homework like this. If you didn't, you're in trouble. With me too. Okay, so what is f at 6? So I'm finding the slope at 6. Slope when x equals 6. So f at 6 is going to be equal to 4 over 6 minus 2. So that's 4 over 6 minus 2 is 4 over 4, which is 1. Okay, what is f at x plus h here? So f at 6 plus h, that's going to be equal to, now I have to plug in 6 plus h where I have the x. So I have 4 over 6 plus h minus 2 is 4 over 4 plus h. Okay, now I'm going to plug those into here. So I have my 6 plus h. So maybe I'll make one more line here if I can make it small enough. So really what you're doing is this, right? So you're doing f at 6 plus h minus f at 6 over h. And here's my 6 plus h. So that's the limit as h approaches 0 of 4 over 4 plus h, that's this one right here, minus this one, the slope, which was 1, f at 6 was 1, all over h. So to make this easier on your eyes and your calculation, I'm going to multiply this by 1 over h. So I'm just taking this and putting it out here. It makes it so much easier to read your work and to figure out what you're doing here. Okay, in order for me to combine these two, I need a common denominator. So let's do that first. The limit as h approaches 0 of 4. So it's all going to be over 4 plus h. So I'm minusing this, right? I'm making this over 4 plus h. So this times 4 plus h in the denominator. So it's going to be minus 4 minus h. Watch your signs very carefully. Times 1 over h. 4 minus 4 is gone. This h goes into this h minus 1 times, and that gives me the limit as h approaches 0 of minus 1 over 4 plus h. Now you plug in the 0, so that's equal to minus 1/4. Okay, so we're doing fine, except I still need some room to write the equation of the tangent line. So I have x equals 6. Let me block this off a bit so we don't get mixed up. Okay, so for the tangent, I have x is equal to 6, y is equal to 1, the slope is equal to minus 1 over 4. And now I just use my equation, y equals mx plus b. Plug in all these so I can find the b. So 1 is equal to minus 1/4 times 6 plus b. And minus 1/4 times 6, that's minus 3 over 2. I add 3 over 2 to this side, so that's add 3 over 2 to 2 over 2. That's 5 over 2 is equal to b. And therefore, y equals minus 1/4 x plus 5 halves. Now, if your teacher wants this in standard form, you should multiply everything by 4, bring it all to one side, right? Okay, I don't have room to do that for you, but you know what I'm talking about if your teacher insists on standard form. Okay, so that took up a lot of room. Let's move on to some limits. So this unit, there was a lot of work on limits, and you had to figure out, does a limit exist? If it doesn't, how do I simplify it to figure out what the limit is? So these show all sorts of different types of limits, and if you're having trouble with these, go back over your unit on evaluating limits and do some more work. Okay, so this says limit as x approaches 2. Now remember, the first thing you should do is if the limit exists at that point, if I plug in 2 and I get an answer, that is the limit. In other words, just direct substitution. Always try that first. So I plug in 2 and I get 4 minus 3 is 1 over 6. 1 over 6, that's the limit. There you go. Done. No problem. Letter B. The limit is x approaches 6 from the left of this. Okay, so here you might want to make yourself a quick little sketch of what this looks like. Using your transformation skills from grade 11, oh yes, this says x minus 6. So this function starts when x is 6, right? 6 is the smallest number I can put in here because 6 minus 6 is 0. If I put in 5, I would have a negative root. Can't do that. So my function is going like this, right? So the limit as x approaches 6 from the left does not exist. It doesn't exist. It doesn't start there. You can't approach it from the left because the function doesn't begin till here. Trick question. Not really. Okay, the limit as x approaches 2 of 3x cubed minus 6x squared over x minus 2. I can see right away that this is something that needs to be factored, right? So here's one where you have to factor. So this was sub, this was a diagram. This is factoring. So I factor out a common factor here of 3x squared, and look what I'm left with, x minus 2. How perfect is that? These cancel out. I plug in 2, that was a 2 here. Plug in 2 here, 2 squared, 4 times 3, 12, done. Okay, this one, the limit as x approaches 3. So when I put in 3 here, I would get 2 minus 5 is minus 3 over 0. So you might know right away that the limit isn't going to exist, but you might also say, well, what if I multiply by the conjugate? Because that is one of the little tools you have in your toolbox to try to figure these limits out. So I'm going to try that. And you're going to see that it just doesn't work. So if I say x approaches 3, so I would have x plus 1 minus 25 over x minus 3 times the square root of x plus 1 plus 5. So you can see I don't have anything to divide this out. Like if this ended up with an x minus 3 up here, great. But I have x minus 24. That's not divisible by x minus 3. So the limit does not exist because you can't divide by 0, and there's no way to simplify that. Okay, let's take a look at this one here. Obviously factoring question, right? Look at all those things to factor. Yes, of course. The limit as x approaches minus 2. I'm not going to do all this factoring for you. I'll tell you what the answers are. So you should have x plus 2. This is grade 10 work, right? 2x plus 1. And in the denominator, you have x minus 4 times x plus 2. These x plus 2's cancel out, which is exactly what you want to have happen, because now in the denominator, you can plug in minus 2 and not have a 0. So if I put in minus 2 here, I would minus 4 plus 1. That's minus 3. In the denominator, I have minus 6. And of course, this would simplify to 1/2. So there's your limit. The limit as h approaches 0 here, so you can see right away that you would have, if you plugged in 0, you'd have 1 minus 1 on the top, 0 on the bottom, 0 over 0. So there is a limit. We just have to find it by doing some work. So we need to combine these two things in the numerator, right? We're trying to get rid of this h down here. So I'm going to write this as 1 over 1 plus h minus. Now I'm going to make a common denominator over here. So I have 1 plus h and 1 plus h. And then again, because I don't like this over this over this, I'm going to multiply by 1 over h over here just to make my life easier. And be really careful again here with your signs, right? Because this is 1 minus h, right? Minus each of these. So 1 minus h over 1, well, I don't need a bracket. 1 plus h is just a common denominator. And I'm multiplying by 1 over h. 1 minus 1, and h goes into negative h minus 1 times. So I get the limit as h approaches 0. Remember to write this out until you plug in 0. Then you don't need to. So I have minus 1 over 1 plus h. I plug in 0 here, and I get minus 1 over 1 is minus 1. Ta-da! How's your limits going? Okay, make sure you know how to do all these different types. It'll be like a fraction one, a factoring one, maybe one that actually works here for rationalizing a numerator, factoring, using your head, and direct substitution, of course. Okay, the last page. Here we have a nice little graph. It says if f at x equals all these is a piecewise function, determine whether or not the limit as x approaches negative 1 and x approaches 1. Do these limits exist? So in order for you to do that, what you really want to do first is see what's happening for each of these where they're joining, right? Minus 1, 1 to 1. So when I put in minus 1 here, I would have minus 1, which is 1 minus 2. That would give me negative 1, right? So when I put in negative 1 here, I get negative 1. So that looks like this is going to meet up, isn't it? But when I put in 1 here, I'd have 1 minus 2 is minus 1 for greater than 1. Oh, I didn't check the other side here. When this is 1, I would have 1. So this looks like a problem right here, doesn't it? Okay, so let's graph it, and we'll prove that what we're doing and we're on the right track in trying to solve this. So we have a slope of negative 1, a y-intercept of minus 2, but we don't go to minus 2 here. It's just to give you idea of the angle here. So we have a slope of minus 1, and at minus 1 we are at minus 1. When x is 0, I'm at minus 2. So my line's going like that. Okay, there's my first line. It's less than or equal to, so I have a solid circle. Now the next line is just x between minus 1 and 1. So at minus 1, we said that was minus 1, but it's an open circle. So it's closing in that one. When x is 0, y is 0, so it's going to go through here like that. And when x is 1, we had 1, and it's an open circle again. Open circle. Okay, and the last little part, we have a parabola, don't we? It's a quadratic, degree of 2. And we said when x was 1, when x was 1, we had 1 minus 2 is minus 1. So means we're down here, and it's equal to. When x is 0, when x is 2, we'd have 4 minus 4 is 0, so that's here. And this is going to go up like this. It's a parabola. Okay, determine whether or not the limit as x approaches negative 1 exists. So we can say, okay, what do we know? The limit as x approaches negative 1 of f at x, don't forget it has to be of something, is equal to. So the limit from the left equals the limit from the right, and the limit is minus 1, so it is minus 1. The limit exists. However, the limit as x approaches positive 1 of f at x, if you come from the left towards 1, you're at 1. Limit from the right is negative 1. They don't exist, right? We're not coming to the same place. So you say does not exist. Ta-da, done. Okay, and here's the graph that you didn't have on your paper because it was one that you have to draw on afterwards. I thought it would just be as easy for me to show it to you here. So a whole bunch of limit questions. That's what this section was on. So let's take a look. What is the limit as x approaches negative 1? Negative 1 from the left is 1, from the right is 1, so the limit equals 1. The limit as x approaches 1 from the left. Now don't think of that as being negative 1. Okay, 1 from the left. 1 from the left is 2. So that's a one-sided limit. From the left is 2. What's the limit as x approaches 1 from the right? 1 from the right. So you're going left from the right. It's also 2. So what's the limit as x approaches 1? Well, we said the limit from the left was equal to the limit from the right. It was 2, so this is also 2. What's the limit as x approaches negative 3 from the right? I guess I didn't really do a good job on this because I put an arrow on this, which means it's continuing. If there was no arrow, well, I would say it's probably a half. It's, by my diagram, that's what it would be. Minus 3 from the right. X approaching 4 from the left. 4 from the left is 1. 4 from the right is minus 2. And the limit as x approaches 4. Well, the limit from the left is not equal to the limit from the right, so the limit does not exist. If I said, what is f at 4? You'd tell me that is minus 1, right? Now, if you have a graph that just ends like we did with the radical one, remember that if there's no limit from this side, the limit doesn't exist. That was the other thing we looked at right at the very beginning. Okay, so I hope that helps you with your unit test. Always go over little practice quizzes or the types of questions that your teacher loves to test you on. Maybe you had a little quiz and whatever. Okay, so I hope that helps you. Have a great day. Keep watching. And don't forget to subscribe if you haven't. If you're watching this and you haven't subscribed, shame on you. Subscribe. I love you. Bye.